Okay, so we have made our graphic organizer. We're ready for the Chapter 7 review with your graphic organizer. Systems of equations and inequalities was this chapter. Make sure your name is on the front. And keep this, it's important. So we had 4 sections in Chapter 7. You can see the first 3 were solving linear systems. So what was the first way we solved a linear system? By
Graphing.
Good job, by graphing. Okay, if we're going to solve a system by graphing, we need to know what is a solution of a linear equation. So what's a solution of a linear equation? We're talking just equations right now, not the inequalities. So what is it, Sophia? A point, an ordered pair that makes each of the equations true, which means it lies on the line of both equations. The point of intersection, right? So if we're going to graph to solve the system, let's put the steps for graphing, and then we'll go try one. So first of all, if I give you 2 linear equations and tell you it's a system, what would you do? First thing you would do is you put them in slope-intercept form and you just graph them, okay? And there's a lot to that. You graph each line. Once you have both lines on the graph, how do you solve the system? What are you looking for, Faith? Once we have graphed both lines, they're on there. What are you looking for? The intersection point. Good. Identify that point that they both cross. And then what is the third step that confirms you have the solution? The third step. Jimmy? You test it where? Good job. He says check it in the original equations. Plug it in, right? Make sure it's true in the 2 original. So let's go ahead and solve this system by graphing. Remember, you've got to be really precise when graphing a linear equation system. Be precise. So in the first equation, we see it is in what form, everyone? Standard. So I would prefer to see it in slope-intercept form. So who can give me the first equation in slope-intercept form? Michaela. Negative x plus 3. So what is the starting point, the y-intercept? 3. So we go plot it. Be really exact. It's hard to be exact on this smartboard. And then what is the slope? If b was 3, what is the slope, Michaela? No, this first one. Negative 1 over what? Over 1. So we will go down 1 over 1. Down 1 over 1. And we could go up 1, but to the left, right? And there's our first equation, okay? The second equation, a little tougher to put into slope y-intercept form. And what is it, Sarah? Good. Y equals x minus 5. One way to do that is to add y to both sides, which moves the y over, and then just subtract the 5. Is that how you did it, Sarah? Or you could just do it the 2 steps either. It's 2 steps no matter which way you do it, okay? So there it is. What is our y-intercept now, Sarah? 1, 2, 3, 4, 5. Okay, and what is our slope? 1 over 1. Go up 1 over 1, up 1 over 1. And there it is. It looks like that point. Right there. So as we look at the intersection, Where are these both crossing right there? Who can name that solution? It might be easier to see on your paper, Lauren.
4, -1.
Anyone else have that? 4, -1? 4, -1? That's what it looks like from here. No one else has it? Lauren, you have it? Who else? I mean, 2 Laurens have it. Casey, Mika. Okay. So we do want to check, and there's not a lot of room. This is it for this particular section of your graphic organizer. So if you want to spread out to the right, if you have room, you could do that. We're checking each in these original equations. So we plug in 4 plus -1. Does that equal 3? It does, right? And we plug in 4 for the second one. 4 minus -1. Does that equal 5? Does it? Yes. So it checks out algebraically, and we have the solution. So after solving by graphing, we went to solving linear systems by substitution. Okay? Okay, we will write the steps to doing this, and then we'll go do one. When we learned this, we actually did one and then wrote the steps, right? So I think you've had enough practice. You should be able to understand these steps as we write them right now. And I'm really proud of how this is set up. Because we said, when you have 2 equations, in the first equation, you just isolate one variable, right? Once you've done that, what do? You have something like y equals x plus 2. What do you now do, Ryan? You plug in the x plus 2 and into where the y is of the second equation, right? That's our first substitution. So we do this. We substitute that expression for that variable into equation 2. And once we have substituted that into equation 2, how many different kinds of variables does this equation now have? It has what? Only 1, right? Only 1. It has only x's or it has only y's. That's it. So because it has only one type of variable, what do? We solve it for that variable. Solve it. And we now know something like x equals 5. We have that. So what do we do with that?
Sub the x back into the first equation.
Good. We sub that value into the revised equation over here or into the original. You can sub it into any of the equations, right? And solve for the other variable. Don't forget, your solution is the ordered pair, right? Not just, there you go. It's not just one number, it has to be 2. It's a point. It's a point where they both cross, just like we saw when we graphed. Okay? Okay, so let's go try that with this system using substitution now. Pause, try it yourself, and come back in. Okay, so what would you like to isolate first? Tell me. In this here, Brandon.
I would isolate x. I mean y.
Y. Okay, so how would you do that?
Minus 2x.
And why did you choose to isolate y?
So it would be in this form. It would just make it easier.
Also, y right now has what coefficient? What number in front of there?
1.
1. So it's the easiest one to isolate. You could isolate x. Okay? So we have, he wants to say negative 2x minus 15. He said slope intercept form. Does it have to be in slope y intercept form? No. Okay. So now what are we going to do with this information, Casey? Let's scoot this over. We know that y equals negative 2x minus 15. So now what?
We substitute it into
Good, we take this whole expression, which is y, and we put it over here in the place of y. We say negative 2x minus 15 is in the place of y, right? Minus 5x equals 6. And now we have an equation with only x's, right? So, Jonathan, how many x's do we have on this left side? And negative 2. Good, negative 7x minus 15 equals 6. And now, what do? Add 15. And we have negative 7x equals 21. And now what do? Negative 7. And so what does x equal? Negative 3. And now if we take this back up and substitute it into the revised equation where y is isolated, then y will just pop right out. And remember, the ultimate answer is an ordered pair. Okay? So let's do that. We plug it in. Y equals negative 2 times negative 3 minus 15. And negative 2 times negative 3 is 6 minus 15. What is 6 minus 15? Negative 9. So it seems that the answer is negative 3, negative 9. And what can we do to be sure? Plug it in, plug it in. Again, you'll know for a fact. And so I'm just going to do this out loud rather than writing it here. We put a negative 3 in here, and what do we get? Negative 6 plus negative 9. What is negative 6 plus negative 9? Negative 15. Over here, we plug in negative 9 minus, what is 5 times negative 3? Negative 15. So we have negative 9 minus negative 15. That's the same as negative 9 plus 15. Is that 6? Yes. So do check it. Okay. Now in this section we want to add one other detail, and that was mixture problems. So we had mixture problems. And it's good to remember there is a pattern you see when you do a bunch of these problems. And who can give me one kind of equation that you kind of know you're looking for? Emily.
It's a math problem.
Right.
X plus y equals.
Right. They typically take the form of what she just said, an amount, x plus y equals sum total. And then the second one? The second equation usually takes more than just amounts into account. It does what, Lauren? Some percent of each, or some, like how many, what percent grams of fat do peanuts have, right? Or what percent alcohol was in that solution, like we did? How much do peanuts versus cashews cost, remember? Those rates, it's rates. We end up multiplying by, okay? Giving us some other total. After solving by substitution, we began to solve by elimination. Good. So I'm going to extend the page. So what is the purpose of elimination? First of all, what did we do with elimination? Somebody? Somebody else? Come on now. Think. What do you do with elimination, Zach? Two equations, you add or subtract them. Good. Add or subtract the equations, and the goal is to eliminate one variable. Same goal that substitution has. There are times we have to multiply the entire equation to create opposite or same coefficients. Okay, so you may need to do that. Once you have eliminated a variable, what do? Solve for that variable. Solve for the one that's left behind. You now know one of the two. Again, you know x equals 5. So how do you find y? Can you sing that? Plug it in, and you have y. Okay? Don't forget, your solution is a point, an ordered pair. Two numbers. Solve by elimination. This system. Again, I'm going to extend the board up. Okay. So this is not just a baby problem, is it? We had easier ones, but I thought if we're going to put one, why don't we put a challenging one as a sample in your notes, right? So what makes this challenging right away? Jimmy? The equations are not both in the same form. And he's saying we could put them both in standard form, and then we would at least have everything in columns lined up, including the equal sign. It needs to be lined up. So how can we change the first one, Jimmy? Don't we want to go with standard form? That's what you said. So move the y term to the left. How would you do that? He's subtracting 3y from both sides. Okay? So we end up with 5x minus 3y equals negative 2. He subtracted 3y from both sides. I'm not showing that. And then when we move the second one over now, we have both equations in standard form. So every like term is lining up, including the equal sign. Okay? And so now, do we have opposite coefficients for our x's or our y's? We don't. We like opposites because when you add opposites, 2 plus negative 2 equals 0. So which of these terms would you like to, or we're going to have to go ahead and use the advanced method of blowing these up. We're going to blow up the entire equation so that we end up with opposite coefficients. So which variable would you like to blow up? Who would like to blow up x? Who would like to blow up y? Good for you, because they've already got opposite signs, right? So if we're going to blow them up, what's the greatest, or what's the least common multiple they both could become? 3 and 2? 6. So let's blow them up so that both of those y's have coefficients of 6. So what will we multiply the first entire equation by? 2. Remember to distribute it to both sides. A couple of you on the quiz only blew up one side, which is not going to give you an equivalent equation. It's not fair. Okay? So blow it up on both sides. We have 5x minus 6y equals now negative 4. And what factor will we use to blow up the second equation? Huh? Oh, I didn't blow up x. Thank you. 2 times 5 is 10. So worried about the right side, I didn't go up the left side. Okay, thank you. Now how about the second one? What's the factor?
3.
The factor here will be 3. Make sure you blow every term up. 9x plus 6y equals, what is 3 times 14?
42.
Good, 42. And now we can simply add these. And these two are opposites. It eliminated our y's, right? What is 10x plus 9x? 18x. And then what is negative 4 plus 42? 19x. And I'm recording this. Yes, people at home, I'm not perfect. Okay, 42 minus 4 is 38. Thank goodness I have this class to correct me. When we divide by 19, what do we get? Yay, x equals 2. And how will you find y? Plug it in, plug it in. Okay, where do you want to plug it in? Top one? Who says top one? Who says bottom one? More people want to do the bottom one. Why? Because it just looks easier? Okay, they say it looks easier. I don't know. 2 goes here. 3 times 2 is 6 plus 2y equals 14. And when we subtract 6 from both sides, 2y equals 8. And so when we divide by 2, y equals 4. And shall we check? We're going to check offline. Okay, solving special types of systems. We know that some linear systems have not just one solution, right? We could have one solution. How many other solutions could we have in a system? We could have, say it, 0, and we could have infinite, okay? So what's going on when we have one solution? What's going on with our lines? If we have one solution, they are, which means their slopes are different. If we have 0 solutions, then what can you tell me about these two lines? They are parallel, so their slopes are the same and their y-intercepts are different. When we use elimination, we end up with a false statement, remember? Like 0 equals -2. There is no true, that's not true, so there is no solution of that system. It was parallel lines. And finally, infinite lines are basically the same line, right? So same slope and same y-intercept. And when we use elimination, we end up with a, what kind of statement? True statement, like 0 equals 0. We eliminated everything. Finally, we solve systems not of equations, but of inequalities. Systems of inequalities. So how does one solve a system of inequalities? You graph each. Don't forget solid dash and shading. But to show your system's solutions, you
Find the shading part.
the overlap part, right? Find the intersection or the overlap of the plane. Okay, so we're just simply graphing one system and we're done. If you're at home, pause the video, do your best, come back and check. Okay, so be sure you have a dashed, a solid, and this region of overlap shaded. Okay, good job.